All right, welcome back, everybody, to day 11 of Foundations of Programming. We're going to continue with where we left off last week, which was objects and classes. Last week, Thursday and Friday, we focused on some assignments that weren't originally in your curriculum. That's because we were very ahead of time. So, to make sure that we harp on and ensure that you understand objects and classes, we got some additional content. So I hope you enjoyed the inventory manager and tic-tac-toe. Depending how fast we're going to the rest of the curriculum will also dictate if we get some more additional challenges. Um, but we're going to pick off from the curriculum because we're back on schedule. And that's going to be working with streaming guide, right? So here's the streaming guide. It's going to be in lesson 8 under the streaming guide directory. And the streaming guide is going to be pretty much a replica of what you guys are familiar with when it comes to Netflix. If you guys remember Blockbuster, stuff like that, right? You're essentially going to use object-oriented programming to replicate a service like Netflix, Prime Video, Disney Plus, and stuff like that. The instructions are pretty straightforward. From top to bottom, you're going to work your way down. You're going to create your basic movie class, which is going to have your title, genre, and director and years, right? All this should be instantiated with the init method. And you're going to have typical get methods like get title, get genre, get director, and year, right? Movie really is not really going to do anything. It's just going to display to you and hold the input or values of what a movie should be. The next is going to be streaming service. The streaming service is going to allow you to create catalogs and add movies that you have created prior, as well as delete movies, right? Just like we know that there's stuff that comes onto Netflix, stays there for some time, or then it gets removed. Some different platforms might not carry the same movies. So not every single streaming service will have the same movie, but a streaming service should have the ability to hold objects, right? This movie objects. Right, so this streaming service should be able to have a catalog, which should have the movies that it has in its service. And then also two different methods to remove or add movies to its catalogs. Finally, we have streaming guide, which is, I would say, kind of like when you turn on your TV, right? Nowadays, every time that you turn on your TV, you have the more modern TVs have applications, right? You're able to have Prime Video, Netflix, Disney Plus. If you're an anime fan, you have Crunchyroll installed into your TV, right? You have a bunch of different streaming services, right? This is what we're going to call our streaming guide, right? So your streaming guide should be able to add different streaming services, delete them, and it should be able to have a method that's going to tell you where to watch a specific movie, right? As you see here, the where to watch movie takes a movie title as an argument and returns a list of every possible streaming guide that is streaming the movie that you're looking for, right? And at the very end, you should have a little code snippet that you're able to copy and paste to kind of try it out. The first line is going to create multiple different movie objects. We see here movie, movie 2, movie 3, and it looks a little weird because I'm using the formatted version of this. Let's go back to code. There we go. You should be able to have 4 different movies. And the code is going to go through the steps of adding streaming services, adding movies and deleting to the streaming services, adding it to the streaming guide, and then finally working with the streaming guide himself. We're going to take about 30 minutes on this assignment. And then after the 30 minutes, we'll come back. If someone finishes, we'll get a code demo. If not, we can talk through the assignment and see how to reach the outcome. But I feel very confident that for the most part, you guys should be able to handle this one. If you went through the inventory manager or the TikTok one, this should be pretty straightforward. So time is 5:45. We're gonna go ahead and return at 6:45. And let me go ahead and pause recording. All right, welcome back, everybody. Who wants to volunteer? Who was able to complete the streaming guide?
I still got a couple bugs. I'm close, but again, I just have a couple bugs I'm working through.
I'm also just almost there.
Yeah.
Okay, sure. Who's absolutely lost that they could use a walkthrough? Be honest.
I
I
feel like
haven't
I'm on the right
tested
track,
mine
but I don't know.
yet.
So Kevin said, also not
No.
Kevin. Michael said it's good. Daniel, I heard you speak.
Yeah, I'm working on the last part of it, where to watch movies, and then I got to see if it even works. See if I'm lost or not. Because
I'm on the same
in my mind,
path.
like I'm right until it doesn't work.
Sure. Okay. Uh, yeah, we'll give it a bit then, and whenever somebody's done, I want you to come on the mic and let me know, and then we can do a walkthrough.
All right. Here's our movie class. Self-explanatory, just a bunch of getters. Streaming class. So the ad movie was fairly simple. Um, Basically, you're just taking the object movie that you created here. I just made a bunch of generic variables, and that's going to add to our key. I didn't use titles as key. I just used numbers because there could be a ton of movies. It's just what I had in my head. So the issue I was running into, and I thought I was pretty confident in dictionaries, but I guess it's been a little bit. I was trying to use the get method for values to get the title. However, I was running into a serious bug that was saying, let's see, tuple object has no attribute. So I couldn't quite decipher that. So I knew the value of title was going to be the first one based on how I coded this. So
Let's
I just kind of
let's
go
talk
ahead.
about that before you move forward. I want to make sure that we understand it because the .get method is a very powerful tool, and you're gonna use it as well once you start working your backend.
Yeah,
Um, so I hope you don't mind. I'm not trying to be rude. I just want to make
go
sure that we
for it.
really understand that one, right? So the get method is invoked on a dictionary, right? And right on the self dot catalog, you are grabbing the key values dot using the dot items, right? So dot items, this returns to you a key value tuple list, right? So it's going to be a list with key value pairs and tuples, right? That's
Oh,
how it returns it to you, right? So what your code is interpreting here, when you use something like you say you use .get here, you
yeah.
essentially were trying to access index one of a tuple and invoking the .get method, right? But even if it wasn't a tuple, this would be wrong because this is a value, right? The .get method is a method for dictionaries themselves. So not on a value specifically, but the entire dictionary as a whole. So you would want to do self.catalog.get, right? Because
Self.catalog
self.catalog
what?
self.catalog.get, right? Because self.catalog is your dictionary, right? The dictionary is what uses the .get method, right?
Okay.
And what this is going to do is going to grab an item by whatever key you pass in here, and then it'll return to you the value, or it's going to return to you none, one or the other. So you're trying to take a title, and I'm assuming you're trying to use that title to grab it from self.catalog. Is that correct?
Correct.
So what this should be is, uh, so this is how the dot get method works for any of you guys that aren't aware. The dot get method actually takes two parameters. The second one is optional, right? But what the dot get method is going to do is going to attempt to grab something inside of a dictionary, right? If it finds it, it's going to return to you the value of itself. But if it doesn't find anything, it's going to return to you the second parameter you pass in, which by default it is set to none, right? Uh, but you are able to give it that second parameter optionally. So instead of getting none, you can return a string that says it does not exist, right? So you can do something like that, right? Um, so this is returned to you. This is a function that's going to return to you a value or none. So with this in mind, what you can use this to your ability is if self.catalog.get is equal to the value, or if it's equal to none, then you do one thing or the other, right?
Oh,
So you can say if self.catalog.get does not equal none, that means if it's not equal to none, that means it found the value in it. Does that make sense?
almost.
Yeah, and you don't want to use a for loop on it because it's not an iterable. It's going to return to you only one value. It's going to be the value of the key, or it's going to be none, one or the other. That's it, right?
Okay, so I can just go through here or just this is what
Yes,
you're saying. I can just grab
correct.
the title and return, hey, it's here or here it's not, or it's not.
Yeah. So I would do a comparison here to make sure it's not none. I don't know how it's going to work if it does return to you none. Um, ideally, I think this should work, or you might have to say not equal to none, right? It would have to be
Oh,
if self dot catalog dot get title does not equal none, something
if
like that.
not. So that would be the same. If not, get title. So if not, none.
Yeah. Then you would return print uh not found in the catalog. So if it's none, you would turn it's not in the catalog. But if it is, you
Yeah.
return it's deleted and you would delete it. Yeah, this should work.
So I'm trying to read. That's obviously a value. I'm trying to get rid of it by key.
Yeah, so passing title in there.
But that's a value.
Title is the key, is it not?
No, it's a value. That's why my
Okay,
code was a little different, a little stupid.
right. It's a value. You're trying to remove
A
how
key based on the value that I found.
and what is this value supposed to be? Give me an example.
So title, genre, director, year. The key that I used was just a number generator or a counter.
Okay, and
Uh,
that's where you might get some issues. Uh, because you're trying you have to look for it. The method wants you to look for it with a title, but now you no longer have that. So you have to check if whenever you use the dot get method, because you're gonna pass in one, two, three, or so on and so forth, because you're using a number. Is that correct?
yes.
Yeah. So once you check, you have to make sure that it's actually equal to the movie you're trying to delete, right? The value of title that you have inside the value section, right?
Okay. So, hmm.
And that's the issue. How are you going to look for it? If all you have is title, but you don't have the ID number, then in that case, you would have to loop through it.
Okay. Well,
Yeah.
all
Now,
right.
now I'm understanding. So this actually might not work because of how you have your dictionary structured. The program wants you to look for it with the title. And I will say, I'm not saying you're wrong, Keegan, right? You're absolutely correct. You probably wouldn't have the title as the key to organize your catalog. But I will say, careful when doing this because the assessment is going to tell you deliberately what you need to do. You need to be able to search for example, in this scenario, you need to search for a title or you need to search for a movie with the title name. And then what the assessment is going to do is going to test. There's going to be pre-built tests that you have to run your code against. And the test is going to be testing for that. That it's going to invoke the delete movie method you created, and it's going to pass in a string of the title. And if you didn't structure your method like that, and you did a number instead, it's going to fail.
Okay.
So I'm not saying you're wrong, but this is what I believe is the issue with test-driven development, right? You obviously your method will work, but according to a test, it's not doing what you're supposed to do. Therefore, you will fail that test, and you might be confused, like why is it not working? Like I'm returning the movie or I'm deleting it, it's successful, but the way the test is going to test out your method is going to passing a string into your method because that's what it's expecting for your method to take, and it will fail. So once again, I'm not saying you're wrong, right? You can reach the same outcome different ways. But when it comes to the assessment, if you don't do it how the test is asking you for it, it's going to fail. So just
So
careful
just
with that.
follow. So follow
Right,
direction.
right, right. Like I said, no, it's good, right? Because realistically, yeah, you might the way this might work actually, especially for a much scalable project, you are absolutely correct. It's not going to be by titles. It's probably going to be some kind of serial number, right? There might be some kind of code that we assign to a movie when it gets assigned, right? I don't know what the standard might be or the SOP for it, but you are correct, right? Maybe names isn't the best way because there's movies that are repetitive, so they might have a movie ID number. So you are correct in that matter. But in regards to these problems or the assessment specifically, uh, you have to think a little bit less open-minded. You have to kind of it sounds a little counterproductive, but I want to make sure you're successful. Your thought process is absolutely correct, and that's how you should be thinking as a developer. But I just want to make sure you're aware of that. Sound good?
No, I appreciate it. That was a good that's honestly a good heads up.
But yeah, you can just press Control Z and then have it all the way back to where we had it before without having to do all this. Uh, oh, you copied it. Oh, that's awesome. Okay, cool. But yeah, so
Oops. Whatever. Making me mad. There we go.
okay, cool. So yeah, I mean, it looks like it's gonna work. You pass the title, you're looping through it. Cool.
Well, it worked the first time.
Right. Now, what
Uh,
about your streaming guide?
so streaming, um, adding it is very simple. I just have it print the streaming service name added or streaming service name deleted. It's a
Mhm.
list, so I just used a pop method. Nice and simple. Um, this uses the same thing as up there. So same issue. Not using title as a key really kind of shot myself in the foot. I kind of put the cart before the horse on that one. But
Let's
if I
run it.
run this, oh, I missed something. Now it's all messed up.
It's okay. 43. It's a dictionary chain size during iteration.
What the hell?
Ah, yeah. Okay, I see what he's doing. You have to return. So what's happening here? You're not returning anything, Keegan. So it's going to delete the key value pair, and then it's going to continue with its for loop. And because you already deleted something, it's confused. Like, yo, you can't delete it. I'm in the middle of this for loop, and you're trying to continue iterating through. I don't understand what you're doing. There you go.
That
Uh,
makes perfect sense. Why?
it's the indentation of that. Yeah, there we go. And then,
Now, this is why I hate copying code and putting it somewhere like a notepad because it
yeah,
just messes all my indentation up.
I feel that. It's okay. Try it again this time. It should work now.
Winner.
There you go.
All right.
Awesome. Good stuff, Keegan. Thank you for that. That was actually a very great example. we were able to talk about other stuff and whatnot. Does anybody have any questions about this assignment or anything that Keegan did? Any of the concepts? Any of these methods? Okay, awesome. Uh, as we go through this, I just want to give a quick disclaimer without giving out anything. The streaming guide, and then lemonade standout pie, which is going to be another problem we're going to do, are probably the closest thing that we're going to get to the assessment without actually doing the assessment. We're about to talk about another concept that is going to be required from you in the assessment that you need to really understand, which is going to be reading and writing files. But this is a very good example. If you did this fairly easy with no issues, then you should feel confident in yourself. Obviously, the assessment is going to be. What's up?
I was about to ask if we can handle this in the lemonade stand, no problem. How's that assessment looking?
Yeah, it's definitely going to be a couple notches up. There's going to be a lot more stuff that you're going to have to use too. A lot of other concepts, but this is a good if I was ranking the assessment from 1 to 10, right? The assessment is like your 10. This was like a good 4 or 5. So we're making progress there, right? But all right, let's go ahead and go on our first 10-minute break of the night. Time is 6. Welcome back. We finished off lesson 8 with the streaming guide. We're going to start today's new lesson, which is importing modules, exception handling, and unit testing. I thought today was read and write files. Unfortunately, it was not. So that's okay. We'll start with this. This one should be a fairly quick lesson, I believe. We'll get into a little bit of unit testing if anyone's not familiar with it, so you can understand how they work. We won't get too deep in the weeds of it because there's a lot of stuff that goes into unit testing, but just enough for you to understand how they're going to work. And what I was trying to explain earlier in regards to how a test is going to test out your code. And if you don't do it, how it's going to test it, you'll get a wrong answer. We should all be seeing, I believe, my slideshow. Yeah, okay, here we go. All right, so the first thing that we're going to cover today is going to be modules. What is a module, right? A module is just a normal Python file that contains definitions of functions or classes that you would like to use in another file. You have been using these, believe it or not. Right? Think of when you guys import random or any other crazy stuff that you imported in your Python file. That was essentially a form of a module. Right? It's just a file that you use inside of a different file. Our code snippets here is we have 2 different files. We have a main.py and we have a mystats.py. Right here, the mystats. The only thing that this mystats.py file has is a function called find mean, right? Nothing but the definition, right? This is just the definition. There is no functions that are running. There's nothing, right? The function is created in a separate file, right? So we keep it away from our original main.py file, where our main program is running. But it essentially still defines our function for us. And now when we come down to the main.py, let's say that we encounter a situation where we need to use find mean, right? This function that we declared earlier in some other location, right? The way that we would leverage that function in our main.py file without having to rewrite it is by importing it, right? Here, line 1 says import my stats. If they're not in the same directory, right? Like you see here how they are, then you would have to specify where to find this, right? But because they are, all they say is import my stats. Now there's 2 ways of doing this. You can import the entire module or file, or you can be very specific and import only what you need. In this scenario, it is a fairly lightweight file, right? It's only 1 function, 5 lines of code. So there's no harm in just importing all of my stats. But in modules or files that you may have 500 to 1,000 lines of code and like maybe 50 different functions, you probably don't want to import everything, right? If you don't need it all. Uh, so in the event that you want to import something specifically, you would specify from my stats import find me, right? And then we'll talk about how we can do those. But here, they just straight up imported the entire file of my stats. Then the main.py continues, right? They have a list here created, um, and now they're ready to find the mean for this list. So the way that they leveraged it is they call the file they imported, and they use dot notation to specify what function from this file you want to import, right? Which is the find mean. Uh, and this should look kind of familiar, right, Michael? What does this look like?
I'm not sure what you're asking.
What does line 3, the way they're using my stats.find mean look like? Anybody want to help them out? Anybody have any guesses?
Class.
It looks like a class, right? It looks like a class. When we created a class and give it methods, we could then use it somewhere else. And that's kind of the example I was trying to convey to you guys last week. That really classes, all they do is just organize our code into a container, right? And then we're able to call that class somewhere else and use the methods as needed. That's kind of what this file is doing, right? The file itself is the container. Here we have a function, which is another word for a method when talking in regards to classes. And when they're trying to use it, they call the file my stats.find mean, which is fairly similar to how we use classes and objects, right? The code is created inside of a class, and then we call the class or object and leverage its functions or methods, right? It's very similar in functionality. Now, obviously, they're not the same thing, right? Don't start comparing these to be the exact same things. They're not. But uh, the concept of containers is similar, right? Classes create a way to contain code that has some similarity or relevance to each other that we can then leverage somewhere else without having to rewrite it over again, right? So that's what they're doing here. They created a function in a separate file. They then import it into whatever file they need to use it, and they use the file .find mean to leverage the function that exists within my stats, right? Finally, they're able to get an answer. So this find mean function was not created in main.py. It is a third-party file, which in this scenario, we're calling a module. And here what I was telling you guys earlier, right? In the event you have a module that has 50 to 100 different functions and whatnot, and you don't need all of that, it's better for you to not import at all. You want to import exactly what you need. So the syntax for that changes a little bit. You specify from where you want to import, and then you specify what you want to import. Here we see from my stats, import find me. And notice that the way we use this also changes because we are no longer importing the entire file. We're only importing the specific function. We can call that function that we imported directly, right? So the way that we're accessing is different. Whereas before, we didn't import the function directly. We imported the file or the module. Therefore, we have to call the module and then the function that we're using, right? So the way that we import it will also dictate how we use it. And now, in the event you have a module with multiple functions, right? Not just one, but let's say there's like 50 of them, but you need 3 or 5 of them. You might think to yourself, do I have to write this multiple times? No. All you do is you separate with commas the different things that you're trying to import from the same module, right? So here we see from my stats, import find mode, comma, find mean, comma, find median, right? So you are able to import multiple functions from one file without importing the entire thing. Any questions so far? See if I can do this real quick. Here, import random. I have a dummy template, right? An example file. It's just called main.py, and I'm importing random. right? When I hover over it, it says module random. You can see there on my screen. And then if I wanted to use it, let's say I want to get a random number. Random number is equal to random.randint. Right? Randint is a method that exists within the random module, right? The random file. And it's telling me how it works. I can put a start and an endpoint for the range that I want. Let's go between 1 and 10. And then I'm gonna print random number. Python make.py. Brightness 5, I run it again, 3, 10, so on and so forth. Right? But because I imported the entire random module, the way that I leverage it or how I use it, I have to call the module I'm using and the method that I'm trying to use. Let's check out where random is at. Right? When you hover over a module, you can right click it and you can go to the definition. Right? You can see where it's at. When I click it here, it tells me the file path of where it's at as well, but it goes directly there. Right? Look at the right side. This is the scroll bar of everything that is inside of this module. It is close to 1,000 lines of code, my guys. When I import it random, I imported literally everything that's in here. Right? This line leverage everything in here. I have access to every single function declared in here, all because of the random import that I have. Let's look for randint, rand range, randint. Notice it is just a function, right? The random module is literally just a Python file that was installed when you installed Python that you are able to use. Whoever tracks how, Python and the updates, whatever, the staff for Python, whatever they are, developers for them, they created this library, provided to its users so they can use, so they don't have to reinvent some of these things. These functions that you guys have been using, randint to uppercase, all this stuff, they're not just magic. There's an actual declaration to this. In the source code, there is a function that someone had to write manually, right? And then they just provide it for you. You don't even really need to know how it's written. All you need to know is how it works, right? That is the whole concept of why we use functions or classes and objects, right? But here is the function. They have a small little description, returns a random integer in range and so on. Notice that it's leveraging another function declared above, self.randRange. And notice the keyword self. The random module is literally a class. Where's the class definition? Class random. Right? These functions are class methods. They're methods. The randint is literally a leveraging the rand range method. Let's look at this one. The rand range method has a lot more to it. And there's someone straight up hard coded exactly how this is supposed to work. Now, you don't want to import all of random. And that goes to everything else that you use. Every other module, you don't want to import the entire module. That is not good practice. So let's change it. From random, import randint. And now I no longer need the random prefix. And I could just use the randint method by itself. Is this new to some of you guys? This concept? No? Daniel's like, this ain't my first rodeo. All right. Now, you can also give your imports aliases, right? Let's say you have a function that is just super long. The random one isn't too bad. Let's see if we can find a long one. Typically, people don't give functions a lot of long names. But if it's something like normal variate, right? This is a pretty long name. And if you're going to use this method a lot, look at this one. Log norm variate, expo variate. Ooh, Von Mr. Variate. I don't know how you even say that. But there's a method that you're going to be using a lot, and it's pretty long to type. And you don't want to keep typing the entire thing out. You can even give it an alias. You can say from random, import randint as R. And now notice that this right here is giving you a squiggly line, so it doesn't understand what this is. I just change it to the R, and it does the exact same thing. R takes the placeholder name for random, and I no longer have to type out all of random to use it. Any questions? Cool. Important issues. If I import the following module and run this file, I get 15. Why? So, Nick, you guys say something?
I was going to say, because at the bottom of the file, it has a print statement and it runs some code.
Right. So, let's talk about that, right? We have our two different files here. We have the calc.py, which is the module, and then we have the main.py, which is the main project folder, right? On line one of the main project file here, they're importing the entire module of calc. Now, when you import a module, it will read your entire file from top to bottom, right? To interpret every single line. And if your calc.py file has a line of code to do something, it's going to run it automatically, right? Because it's going to read your import from top to bottom when you import it in, right? Maybe that's not something that you always want to do, but what if you do have a file that has a bunch of functions, right, that you want to use in other places, but also this file has a task of itself to do something, right? Not only does it have other methods in here that you want to use other places, but you have actual code that you want to run. Then you run to the next problem. What happens if I want to import it to a different project and I want to use a method here of moat or add? I don't want to have to manually import every single method. I want to import the entire module, but I also don't want this print statement to run. How do I stop it from running? Well, that's when the next concept of main functions comes into play, right? And this can be a little confusing to describe, so I'll try my best. If the file's imported, underscore name will equal the name of the module, and the file won't be executed. Let me just show you instead of actually reading the slide, because it can be very confusing. When you run a file, by default, that file is called the main, right? That is a name that your computer understands, right? Think of it like it's like the main character. When a file runs on its own, it is its own boss. His name is called the main, right? When it's imported somewhere else, it shouldn't be the main folder, right? I'm using it as a third party, right? I'm like a way to enhance my project. I don't need my that module to run everything like he's leading my project. No, I'm just calling you in because I only want to use your methods. You should not be running your file entirely because you're not the main character in the story. I just need to use your functions. Let me see if I can do this. Let's say print. I think it works. Main. Is it not gonna work? Oh, if name is equal to main, I don't do this often. Give me a second. Print name. Actually, no, that's not what I want. Print name. I want to visually show you what this is. Oh, there we go. All right, so I ran this file called main.py. I am printing this thing called name, right? This is, see if it tells me. Go to definition. It won't tell me. The underscore name underscore is referring to the file, right? Because I ran this main.py file on its own individually, right? I didn't import it somewhere else and run it. I called the run function directly, right? I said, I am gonna go ahead and say, let me come in here instead of using the root cd lesson 09. I'm saying Python main.py. I am running this main.py file directly, right? Because I am calling on this file, he is main. This is the main character. This is the main file, right? That's why its name is main. Now let's try use other main.py. I'm gonna go ahead, I'm gonna import main.py or main. I'm not gonna run main.py. I'm gonna run other main.py. And not exactly what I was looking for. I import main, and then main is printing out name, but it gave me main, but not underscore main. So it's a slight difference. But what I'm going to do here is I'm going to add some code that you probably seen before, and it's if name is equal to main, and all of this, I'm going to wrap it inside of a function. And what this is saying is, hey, if the Python file that's being ran is equal to the keyword of main, then I want you to run random number. If not, it's not going to run it, right? And as you saw here, when I ran the other main one, it was not equal to underscore main, right? It was just main itself, right? That tells me that when the other main.py file ran this main.py file, the main.py was not the actual main character in this story, right? Therefore, it was not equal to main, right? That also means that main.py was not being run on its own. It was being ran when it was being imported into a different file, and that file was being ran. So it was being ran almost like a third-party file, right? So now when I run this, notice that it didn't give me anything back. When I run other main.py, it doesn't run this code that was in main.py. Other main is importing the main file, but because of this logic right here, when main runs due to other main being ran, it understands that it is not being ran individually on its own. So it's not going to run random number. But if I run main.py directly, making me look bad, my friend. Python main.py.
Is it because they're both strings or?
Probably. I don't run this often. Name, there you go. There you go. Now I'm getting what I'm looking for. Main.py. Right, when I run main.py directly as an independent file, it will run this random number. Right, but when I run other main.py that's importing main, it doesn't do anything. Right, because it understands that I am not being ran individually. I'm not a solo file. I'm being used as a module somewhere else. Right, so what this allows me to do, in this other main file, I can import all of main and then use random number should be main.random number. As needed, and I can do stuff like this. Print, hello, I have a random line inside of main. Import main. What the hell? Why are you running this?
You have to put that inside of your if name equals main statement or no?
Yeah, I do. Because I'm gonna read the file from top to bottom. This one, I'm gonna run the random number one whenever I have this here. There we go. But the functionality is gonna depend on who's running the main.py. Am I being ran on my own? Or am I running because somebody else is calling me inside of their function or inside of their file? Right? So main is just checking who is the main character here. Right? If the file is imported, __ name will equal the name of the module and the file won't be executed. If the file is run as a script, as in what you call it, by itself, right? Like how we do Python and then you call up the file name, then it will run that, right? So this line of code 13 and 14 allow you to run scripts individually. I don't do this too often, but if you like to do stuff like scripting, to automate different things on your computer, this is very helpful. Any questions before we move on? Awesome. Basic stats.py. Let's see it. So you're going to import the statistics module. And you're going to do this within a object. You're going to write a class called student. It's going to have two private data members, the student's name and grade. Right? It should have an init method that takes two values and uses them to initialize these data members of name and grade. It should have a get grade method, a standard get method to grab the student's grade. And then you're going to write a separate function, not a part of the student class, called basic stats that takes as a parameter a list of student objects and returns a tuple containing the mean, median, and mode of all the grades. When you import basic stats, make sure you only import the methods that you are trying to use. If you need to know more about mean, medians, and mode, you can check out the documentation for the statistics module. So it should look something fairly similar to this. We instantiate 4 different student objects. They get assigned into a list. And then we pass in this list inside of the basic stats function that we are creating, which should run the methods that are coming from the statistics module. It's a fairly simple one. We'll come back at 7:30. Give it a try. Can we get a volunteer for the assignment?
I can volunteer.
Let's see it, Justin.
Okay. All right, everyone can see that?
Yes, we can.
Okay. Yes, I mean, had to volunteer from this one because it was the short, easy one. But here at the top, we've got the import for mean, median, mode, and from statistics. Pretty straightforward. Initialize the variable, not motives, initialize the methods of the variables and the arguments within them. Made the get grade, and then the way to get all of these grades and throw them in to these equations was by using a for loop using the get grade method on each student in the student list. So yeah, pretty straightforward. And since we imported just these sections, you just put mean, median, mode, and then it returns all three of them in a tuple. And so down here you've got everything. Up down here you've got everything laid out, and so we can just run it, and we're good. 74.75, 74, and 74. I don't know
Awesome.
one's afloat and one's not, but hey, it is what it is.
That's okay. Yeah, good stuff. Uh, yeah, I got no other questions. Pretty good. Like it. All right, let's go ahead and continue. Pretty straightforward.
Oh, I guess it's because the mode didn't involve any fractions.
Other than busy. Oh, Lord, I'm getting sick, man. My kid came down with strep throat. The back of my throat started to get swollen. And
And we just had that like 2 weeks ago.
it is horrible, man.
Yeah, it's not fun.
I don't know what it is about us dads that whenever we get sick, it just puts us in on our butt, makes us bedridden. Oh, I'm getting chills. Okay. All right, let's continue. So that concluded basic stats. The next is gonna be exception handling. Right. So up to this point, and for those of you who just started your coding journey recently within the last month or two, um, you've encountered a lot of errors in your code, right? A lot of the times, especially when you first start off, you didn't know what half this stuff was. The initial issues you would encounter starting off were syntax errors, right? And typically, a syntax error refers to you have pretty much improper grammar, is the best way of placing it, right? You missed a colon somewhere, right? You didn't use a comma, you didn't close off a parentheses, quotation mark, something of that sort, right? That is the syntax of Python. So typically, when you get a syntax error, you know, if you understand what it refers to syntax, you would know that it's somewhere in your code you forgot something, all right, or you maybe added a little something extra somewhere. But as you guys progress through your time here in Platoon and through your journey in tech, you're gonna run into a lot of other issues, right? A bunch of other errors, right? You probably seen value errors as well. These are all essentially different errors that you might encounter, or you also might encounter exceptions, right? And the issue with exceptions or errors in general is the fact that they're going to stop your code, right? It will stop in the tracks. Python because it uses an interpreter to run. I feel like errors are more prevalent than if you were to code in a different language like Java or C Sharp, where it compiles your code prior to it, right? Uh, because Python uses, I believe it's called dynamic typing. When typing in code, you don't have to specify when a variable is a string or if it's an integer, right? If you're using a dictionary or a list and stuff like that, you don't have to be very verbose with your naming or declarations of your values. Uh, Python kind of guesses what you're trying to do, right? If you put in a number without quotation marks, it assumes you're referring to a number, an integer, right? So it dynamically assigns it that value. But that also leads to more errors, as I feel, right? Because we have so much leeway of how we can create stuff, and not much supervision from our interpreter or from a compiler specifically, that it leads to a lot of issues. So we're gonna talk about exceptions, right? Errors and how to deal with them, right? To ensure that your code doesn't stop as frequently, right? Um, and don't fret if you don't understand it right off the bat or you're not good at it. That's okay. As you progress through your time here, you're going to realize what kind of errors you might encounter. For example, trying to iterate through a list using a range. What issue could you lead into when iterating through a list using a for I in a range?
Going over the index.
Right.
Out of
A-
bounds.
out of index, right, is typically the actual verbiage it gives you, but you correct, Nick. Out of index range, right? If you try to access a value in a dictionary, you will get an error if you don't use a .get method, all right? Stuff like that. These are issues that you will encounter if you try to do something with a value and it's like no or none. All right, if you try to add something and one's like a different data type. Uh, and as you get more experience with coding, you'll realize that what errors you might encounter, and you'll come to find out as you're typing, like, oh, what if this gives me this error? Let me make sure I take care of this in the event I do run into it, right? So you start doing stuff like try and except blocks or exception handling, right? And that's what we're going to talk about, right? And the reason we do that is in the event that your code does run into this problem, you provide a way for you to debug it or a way for your code to handle it and just continue doing what it should be doing, right? Because ultimately we don't want our code to just stop, right? They would defeat the purpose of writing a program if we have to have like physical interference between with a human being. What's the point at that point, right? It's not automated and it's not doing what it should be doing without your interference. So the first one that we're going to talk about is going to be the try and accept block. And I've seen a couple of you guys use it already, and they're very powerful. I love them. I encourage you guys to get good at them. They provide you with a great way to handle when something goes wrong. And I did mention to you guys the last time we talked about try and accept blocks, is just be a little careful with how you use these. When you go to use a try and accept block, you shouldn't be putting 50 lines of code in the try block, right? And the reason for that is because if something fails, the entire try block will fail. And it's going to resort to the accept line, right? And it can make it very difficult to debug, especially when you don't know where it might have failed. You're going to find yourself putting print statements at every line to see how far your code got. And then you'll get irritated to a certain point where like, all right, I'm just gonna take it all out of it, this try and accept block and figure out where the issue is, right? Because what will happen is you'll add an accept block and you might have something like this where we have the exception zero division error, or just you'll have something that's supposed to default to, and instead of giving you the error you wanted, you're gonna get the print statement you added here in the accept block or whatever, or however you schedule this out. Like here's a prime example of how the try and accept block would work. Right, we have a variable called numerator that is doing 10 to the power of 3. And then we create a variable for denominator using the input from a user, which is then converted into an integer, right? Because we know input method returns to user string. Now, the next step was to divide the numerator by the denominator. But what happens is some goober gives us a number that is 0, right? Or something that we can't divide. So here they put it all in a try and accept block. In the event that we try to divide numerator by denominator and it doesn't work because they gave us like a number that's 0, right, or a number that's that shouldn't work, it's going to default to line 7 and print out division by 0 is undefined. So you set a do this. And if it works, good, we'll continue on. But in the event it doesn't work, this is what I want you to tell me so I know it doesn't work, right? It's close to like an if or else block, but it's a much more elegant version of doing it than having a bunch of if else statements, right? Here we see it. They added the 5 as the denominator. They did the division and it worked. The second time they ran this, they added 0 as the denominator, and they tried to divide it. It failed, therefore resorting to the accept block of 0 division error, and they got this. There are some predetermined exceptions already, right? That you're going to encounter. So where is the 0 division error come from, right? These are, I don't think this one is actually, if I'm correct, but there are some that are predetermined. So, for example, value error is a fairly common one. So if you do a try and accept block and you type out value error within the accept block, it's going to recognize it, right? Because it's built into Python. So it's going to know what these are. But there's some times where you might want to create your own exceptions, right? Maybe whatever you're doing is very specific and Python doesn't have something built into it. So in that case, maybe you want to create something that you can specifically look for that's more relevant to your program, right? And this is it's done by the way of creating your own exception blocks, right? Now, this isn't something you're going to be using all the time. It's good to know how to do it. If you need it, you're going to need it for your assessment. So just make sure you pay attention. But the exception class, and that's what it is. The exception is a class, right? It's a class that's made by Python, right? That we have leverage to. Well, we can use this class and we can create a new class by the way of inheritance, right? And I spoke a little bit about this earlier on in the object-oriented programming lecture, the day one, I think. But you are able to inherit from a different class and use its functionality, similar to how a parent passes off traits to their child. We do something very similar to that, where we can create a class, which is it's called derived class is the term that we call it, or the child class, right? And it's going to derive off of a parent or the base class is what we call it, right? And notice here in our code, we have on line 1 class imaginary number error, right? This is a class that we are creating ourselves, custom made. And then we open and close parentheses right after the class declaration, and we pass in exception, right? So when you want your class to inherit from a different class, you pass it in using these parentheses, right? This tells your Python interpreter, okay, you are creating a new definition for a new class, and you're leveraging the exception class that already exists. Now, what this does, it gives imaginary number error the identity of an exception. So it's essentially going to work as an exception, right? It's going to have the functionality of it. But we don't want to change anything, right? The only thing that we're doing here by giving imaginary number error the inheritance from exception is to be able to use it as an exception, right? We can talk more about how we can customize exceptions to do more specific stuff. But as of right now, the only thing I want is my Python interpreter to be able to identify this as an exception. So when it reads imaginary number error, it knows this has the qualities and appearance of what an exception should be. Therefore, I'm going to recognize it as such. Does that make sense? Cool. All right. Then because of that reason, we just put pass, right? We don't want to change anything. We're not going to give it a new init method, right? It doesn't need anything crazy. We're not going to initialize the characteristics that come from exception. We don't need to do anything crazy to like customize it right now. The only thing we want is just being able to rep the status of this being an exception. Here on line 5, we ask for a positive integer from the user. And then we do an if-else statement here. We're checking if the input from the user is greater or equal to 0. And if so, then we do to the power of 0.5, right? But in the event that it is not greater or equal to 0, I want to use my customized imaginary number error. And because this is a custom exception, right? Custom, it is not essentially built and recognized by Python. Python doesn't know how to handle it. So we have to raise it manually, right? So in the event that this if check fails, I want to raise imaginary number error. By default, when you do something wrong, like, using the wrong syntax, right, out of index, like we talked about earlier, Python recognizes these because they're built into Python, so it will raise it on its own. But because this is a custom-made one with no actual definition, we're going to have to raise it ourselves. So that's what we're doing here on line 10. We are raising imaginary number error. What this does, we are forcing our code to fail, right? We are forcing this to fail. So it does not continue moving on, and we stop our code, right? So we are abruptly stopping our code ourselves. So we are able to raise imaginary number errors. Any questions on this? Okay, just understand at this point right here, we're raising an error. We're not handling an error. We're just raising it, right? Ain't no handling here. This will fail. When we raise this, it's gonna stop our code. Now let's talk about how we can. Oh, okay. Is there another example? No. Okay. So who can guess how we can handle this error if we encounter it? Let's look at it because there's no example here. I'm gonna use this code as an example actually. I want to. Oh, Jesus Christ. Okay, here we go. I'm gonna say class imaginary number error exception pass, and we have user input is equal to int input enter positive integer. Stand by. I should have prepared this earlier. My apologies. All right. So as I mentioned before, right here we have our imaginary number error. We're going to ask for input, and if we don't get it, we're going to raise an error. So I'm gonna run this file, Python main.py. It's asking me for a positive integer. I'm gonna put -1, and it stops. Actually, before I do it again, let me go ahead and print. I am continuing, so we can see how that works. Here we go. I run it, -1, and it stops my code. It does not. Oh, I have an issue anyways. Oh my lord. Sorry for this. Once again, and it stops my code, right? So I check, right, if it's greater or equal to 0, which it's gonna fail because I gave it a -1, and it raises the imaginary number error on line 9. Therefore, it's gonna stop my code. Line 11 never ran. We abruptly stopped our code. Now, well, Roger, why would you want to do that? Like you say, we want to catch customized errors, which is cool. I'm able to make a custom exception like this to track something that isn't already tracked by Python. But then what's the point? It's going to stop my code. Well, that's where the try and except block comes to play, right? We can say try. How do I do this? Yeah. Try all of this. And if it doesn't run, right? If this doesn't work, not run. If user input is not greater or equal to 0, then I want to raise this imaginary number. But now with the try and except block, I can say except imaginary number error, and I can print out something like the number needs to be greater or equal to 0. So now when I run this and I give it the -1, I'm able to manually raise this error and not actually do the user input to the power of 5. I'm able to tell myself or anybody using my code that whatever tried to run failed because of an imaginary number error, and it's able to do the rest of the program that it has to do, right? So you're able to create a custom error that you can raise yourself and then catch, right? And that's the important part of the try and except block is that whenever you're using a custom error, ideally you want to make sure that you're also catching it, right? You're not just going to create errors and just put them everywhere. because that would just stop your code. You want to be able to, you want to be able to catch issues in your code that you don't want to happen, that Python currently doesn't have it built in for it to track. But at the same time, you also want to be able to handle those errors. Don't just create problems to your code and not find a way to how to deal with them, right? So the raising of an error and the except block go hand in hand. Any questions here?
So the accept block doesn't raise the error by itself.
Correct. The except block is going to catch it, right? So when it gets to line 10, because this will pass, right? If I don't add like if or else block, this will pass anyways. This could fail. Let's say print. I didn't do the final result, right? And let's see how this works real quick. Right, so this won't fail, right? Although user input is not greater or equal to 0, I still didn't do anything. I did print out line 10, but it didn't raise an exception. Therefore, I didn't catch it because that's what I'm catching here. The except block is only doing except if I get imaginary number error.
Gotcha.
Right? So you have to manually raise the error so you can catch it in the except block. Or you can also do another except block. You can chain these except let's see. Let's see if I did this right. Right. I didn't do the final results. It should does the catch this.
So is the idea that the imaginary number error will catch that and the other one will catch anything else that happens? So you can be like, oh, well, it wasn't an imaginary number error at the very least.
Yeah, let me actually add an error here. Hold on, give me a second. My family's at the door. How dare they? Be back.
Did you check over that check winner function,
Oh,
Justin?
yeah, it was actually really straightforward. It was clever. I'm like, oh, you just look, it's like a score-based game now. It's like if it equals 4, you win, sort of
Mhm.
thing. Really clever.
Right, so
Hey, Roger, quick question.
yes.
Is that if block stopping from negative numbers showing up anyway? Or is the try block still pushing it through?
No, so sure, the if block won't actually work, but that's not an error. Right? That's not an
Right.
actual error. That's not a syntax error. It's not a value error. It's not something you can't magically do. This does not cause an error in your code, but this will. And
Okay.
now, when we run this, what the heck? Uh, it did not show me this. Let's see if I can do else. Yeah, I think it caught that one too. Why is it not working? Am I doing the wrong thing? That should fail. Oh, I think I'm dumb. I'm sorry. I am dumb.
I don't
This
think
is
you're dumb.
this is gonna work. This does work. That's why it wasn't working. Uh,
Yeah.
you
So
you
maybe
can't.
like hi times hello?
No, that'll work too. You want to see how that works?
Yeah.
Yeah, actually, literally, it concatenates it. That's why.
Oh
Sorry,
no, I said another string hi, not 5.
see, hello, 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 hello. It was working. This actually Python can do that. You can multiply or add numbers to strings. Um, and because dynamic typing, this works. But let's see, how can I do this? How can
Uh, I think the
Like,
Keegan's idea of a string times a string would work.
Oh, sure, yeah, we can definitely do that. Hello times goodbye. Let's see if this works now. There we go. So this obviously didn't work. This is an error. It might be a syntax error or a value error. If I don't add the except block, it should be a value error, I think, actually. Uh, type error. My bad. Can't multiply sequence by non-int of type string. Right? So you are able to chain the except blocks. This one specifically catches the imaginary number error, while the other one will catch any other generic error that it might encounter, right? So you can set it up like this, right? You can do like this, but this will never run, right? Because we're never raising this error. The other errors are being caught because Python manually raises them. It's able to track for that. But this error right here, Python doesn't know what it is. Sure, we declared it, but we have to raise it ourselves, right? So this has to be else raise imaginary number error. Actually, let's keep this in here. Let's see how this works. Right? It never raises a value error because I didn't get here. Because we raised the error. Therefore, if something failed here, I got some kind of error here. It raises the imaginary number error. So it never even got here. It went straight to this line of 13 and 14 and printed out the number needs to be greater or equal to 0. That was the next thing I was trying to tell you guys, right? If your code fails anywhere in your try block, you might have other stuff in your code that should fail, but it's never going to get to it because the try block will quit immediately once it encounters an error. So it can be very complex to handle try and except blocks. So you gotta be very careful with these. Does that answer your questions?
yes, it does.
Awesome. Time is 7:57, guys. Let's go ahead and come back at 8:07 and we will continue with class. All right. The assignment to try this out is going to be the out of range assignment. It's a pretty fairly easy one. It's only a function. So take the next 5 minutes to finish out of range dot py, and then we will continue with today's lesson. Thoughts about the out of range example? Was it too easy? Anybody? Any feedback on the out of range assignment?
I think so.
Do I need to cover it again or cover it once before we move on? Okay. I am taking your silence as compliance. So we should be able to move on. All right. I'm going to share my screen. Okay, so the outer range one, we're not touching it because it was really simple. Simple function. Really, if you walk through with me on the last assignment right before I cut you guys off, you would have known how easy it really is. You pretty much had the answers about raising the exceptions. So very straightforward. Let's go ahead and move on. The next thing we're talking about is going to be unit testing, right? Unit testing refers to testing individual units of code to make sure they work correctly before integrating them with your larger code base. So there's two ways of working with unit tests. One, which is more common, is you create the unit test first for stuff that you're trying to create. All right. For example, if you have a function that's supposed to log your user in, you know that this function should be able to take certain arguments, then you can create the unit test prior to it, and then you want to know like what the correct answer should be. So you can use that correct answer as like an answer key. And then you use that test case to understand how like or what you're trying to create, and then you create the function and test it against it. Or you can write your code, and then you can write unit tests to test possible scenarios where it may go wrong. So there's really two ways of doing it. Um, Unit tests are cool. They're all right. I'm not a big fan of them. They test very specific things, but unit tests are important to know because that's how you're going to be graded as you progress through the course, right? So when it comes to the immersive program or any program actually, you're going to be assigned your assessment, right? Typically, the assessment will open up noon on Friday. All right, so class will run until Friday. Before any big assessment, we do a big review. So everything that was covered the 2 weeks prior to that, we essentially do one big like speed review Friday morning from 9 to 12. And then once 12 hits, we cut you guys off for lunch and we open up the test for you guys. So you guys go and you are able to work on the assessment throughout the afternoon on Friday, and then you're supposed to complete it over the weekend. All right. With this unit test, I'm sorry, with this assessment also comes a file which already has pre-built unit tests in it. You're going to run these unit tests that are already pre-built against your code. Now you're not supposed to change them. It won't work if you change them because once you put it on once you send it up to GitHub, we check it as well. So if you think you're sly, you're going to change the unit test, you're not going to get away with it. But if you write your code and it does not pass the unit test, you will know. You'll be told how many unit tests you have to pass. The more complex assessments have between like 20, 25 unit tests, and you'll have to pass about 80% of them. So it's important that you understand what the unit tests are. There's a lot of different ways that you can create tests for different things. The way that you test your front end is different than how you test your back end. And there's different other programs or modules that are helpful in testing. But we're going to focus on unit testing because it's very simple, the unit test module. And it's also what we're using for our assessments, for some of them, right? This unit test is a class that's going to come with a bunch of different other methods already pre-built in, right? So where we get this information really is going to come from the documentation. If you want to figure out more about the unit tests, the methods they have, I encourage you to look up the unit tests, Python unit test. They have here the Python documentation, the unit test module, and you can read through their different types of methods and how they work, as well as code snippets to really understand what they're doing. So if you want more information about these, then have at it. But we're going to go ahead and talk about the most common ways of unit tests and how they work. So unit test is going to work with assertions, right? Assertion is pretty much what your test is testing and what is it testing against, right? So here are the top, I guess, 10 different assertions that you're going to encounter. And they're all pretty much called the exact same thing, asserts, and then they were like equal, not equal, true, so on and so forth. So for the first two, this method or function is testing if something is equal or not equal, right? And these functions or methods are going to take certain arguments. For example, assert equal is checking that A and B are equal to each other. Where not equal is checking if they're not equal to each other, obviously, right? You have the same thing for true or false, right? You pass in something, right? Asserts that P is true or that P is not true. You can check if something is something, right? Assert is A, is it B? Is A B or not B? You can check if something is inside of something, right? So assert that A is in B. Like think about dictionaries, lists, right? Same thing with the not in. So you're checking for membership checks. And then you can check for decimal points. It can be very confusing. Check for decimal points sometimes, right? Because the floating points might not be exactly how they should be. So you can check if something is almost equal. So you assert that A and B are equal to n decimal places. So there's different assertions, and there should be more, I believe, that you can check through. These are gonna be the most common ones, and we're gonna use these as an example. Writing unit test syntax. All right, so here we have a test file and a unit test file, right? So we have the regular file itself, right? List funcs. Think about your actual code when you guys are writing your code, your program, your functions. This is the list funcs.py. That's what that is, right? And then we have the unit test file itself. All right, the unit test is importing the unit test module so we can use the class and its objects. And we also have to import whatever items we want to test out, right? Here specifically, they're testing out the function listMax. So they import list funcs, import listMax, right? Because we were trying to test out this function to make sure it's working. Now, when creating the class, you have to inherit from unit test.test case, right? This is not magic, right? This is the actual class itself. Where do we get this? Once again, the documentation. All right, so we have to inherit from this class to make sure that test list max has the abilities of testing your different functions. Right? Think about the exceptions. We have to import from the exception class, which is already pre-built, so we can make our own custom exceptions. Same thing here. We are importing from the test case class to make our own custom test cases. Right? It is inheriting from it. Inside the class, you're going to define your different functions. I think, if I remember correctly, off the top of my head, I believe these have to start with the keyword test. If I remember correctly, well, we'll check it out. Oh yeah, it does. Every test function needs to start with test. I don't write this often, so I apologize. But yeah, so every test, whenever you create a new test for it, you have to prefix it with the keyword test. Whatever you say afterwards, it's going to be up to you, right? But here, we have our first test that we create within this class, test_1, right? Inside of this test, notice they do two things. One, they create a predetermined list already, right? We have a list 6, 43, 18, 109, 85. And then we use the function that we're trying to test out. If this works correctly, list max should return to me the max value inside of this list. So it should return to me 100, right? It should return to me 100. So I pass in my test sample inside of list max. And then I use self.assert equal. I use self because this is a unit test class, right? We're trying to use the methods that come with the unit test class. So I have to say self, and then I use the methods .assert equal, which comes from the unit test. And notice I pass in the result of my function and the correct answer, right? So it's going to check if my function does accurately return to me the max value of a list. And this should work, right? If I coded my list max function correctly, this should return to me 100. Right? So I pass in the correct answer because I know that's how it's supposed to work. That's why we create dummy data to make sure we can test it. And it should return true. Right? If this fails, this is going to raise an error. Let's look at the next one. Test 2. Here we're testing our same function again. But this time, the scenario is what happens if we have a list with nothing but negative values, right? So a list here has -7, 1, 38, 2, and 99, all negative values. We run our function again with the dummy data, and we know that the highest value here, right? We know the correct answer should be -1. So we test the correct answer against what comes back from the function that I'm running and check if it's equal. Does this make sense so far? Okay. No silence is compliance. Finally, the last thing we do is we add a name function here where we run our unit tests individually as a script. Let's see how this works. So I'm going to create a function here. Define sum of all values. It's going to take in a list of nums. And I'm going to say sum is equal to 0 for I in range, or for num and list of nums. Sum plus equals num. And finally, return sum. All right, pretty self-explanatory. Very simple function that we're going to test. It goes to a list, grabs every single item, and increases your sum by -0. This should work. Now, let's go ahead and create our unit test. We're going to import. I'm going to move this out the way. We're going to import unit test so we can leverage the class. And then we're going to say from other main import sum of all values. And I'm going to say as s because it's a long name. I'm then going to create my test my functions. It's the name of my class. You can call it whatever you want. I'm going to inherit from unit test dot test case. Right. Call your test whatever you want. But we have to inherit from the test case class from unit test. Right. So it has the abilities of asserting. Next, we're going to create our method. We're going to say test1. And I'm going to create a fake list. I'll say a list is equal to 1, 2, 3, 4, 5, 5, 9, 12, 14, 15. This should return 15, right? Returns 15. Next, I'm going to say result func is equal to s, and I'm going to pass in a list. And we can then say self.assert. I'm going to check if it's equal. Is the result of my function equal to a list? No, my bad. It's equal to 15. The correct answer is 15. My apologies for misspoke. The result of my function equal to 15, which is the correct answer. Finally, we'll add the main function. If name is equal to main. If so, I want to run the unit test, and this is how you run it. I always forget the command. Unit test dot main open and close parentheses. All right, this is how it runs this. This is from the documentation, if you're curious about that. Finally, let's go ahead and run main.py. So, it's important to know. When we run this function, depending on how many test cases we have, we're going to see multiple dots here, right? Because there's only one test, we only see one dot, right? A dot is going to signify that it passed. I'm going to create a couple other ones right here so we can see how it looks like. But it's going to signify that it passes. And then you're going to see at the very bottom how many tests you ran and how fast. Ran one test in 0.000 seconds, and you get a status of OK. This is how it should look like if everything that you did worked correctly. Let's add a second one here. Define test2 self a list is equal to I'm gonna use bigger numbers just for the sake of it. right? And then I'm going to say self.asserts equal result of function, and the correct answer should be 5, 6, 7, 8, 9, 10, 1001. Cool. Let's run it again. Here we go. I run it again, and I see I have 2 dots, right? That's how it should be. Now, let's see what happens. Let's create a separate function. Define. What's a good function that we can create to test out? Anyone got any ideas?
Count letters in a string.
Counting letters in a string. Yeah, let's do that. We can do that. Count letters. We're gonna have here my string. Now we're gonna have a counter is equal to 0. We're gonna say for char in my string. Counter plus equals 1. Now, what could go wrong here? How could this function possibly fit? If I coded this function out, how could I possibly mess this up?
If it counts the spaces and not just chars.
Yes, absolutely. As it stands right now, it'll count anything. It'll count spaces, special characters, and numbers. So let's try that out. In my main.py, I'm going to import that as well. I'm going to say count letters as C. And let's test that one out. Define test3. So a string is equal to hello Keegan.
Hi.
And then we're going to say result of func is equal to C. We'll pass in a string. What is the correct answer for this one?
10.
You're correct. It's 10, right? This should be 10. So we're going to say self.assert equal the result of function, and it should be 10. What's going to happen, this is going to fail because obviously we have a space here. It's going to count it, and it's going to return 11, right? So now, if I run this, I get this, right? So at the very top, like before, we see the dot for the first 2 tests that we took. These passed. The third one, it failed. That's why it shows me an F, right? So it failed. Next is I get the test that I failed here, and it can be a little overwhelming at first. You want to start from here because if you have multiple of these, just look for this test 3 or whatever the test is supposed to be called. And then the next part is going to be the error itself. Really, what you want to look is the assertion. What is this test and what is it doing? Well, usually it helps if you come to the test file and look for the test that you failed, and you'll see what it's testing, right? If I came here and I saw this, I would know it's testing for my count letters. So this it's checking my count letters function because that's what C is. Actually, let me remove this. It'll be easier to read because you won't have that in your real test. We're not going to add aliases. What's going to happen is when you come here, because I failed test 3, I'm going to see what is it doing. Oh, shoot. It's my count letters function. I thought I wrote that correct. And then I see what they're going to be comparing it with, a string. That's what they're passing in my function. And I know that I'm supposed to count letters. Like, why is this? Okay, I'm getting 0. I'm sorry, I'm getting 10 here. They're saying that the answer is 10. The assertion error is saying 11 does not equal 10. But which one's 11? Well, look at the assertion. The one on the left is the result of your function, and the correct answer of 10 is on the right because that's how we ordered it right here in the test case. So I know that the 11 is what my function is returning to me. So this function is returning the correct count. The assertion error is that 11 does not equal 10. Therefore, this test failed. That means that this function is not doing what it should be doing because it returned to me the wrong answer. Right? Does this make sense?
Yes.
Awesome. Let's
Could
see.
you go over the if name equals main one more time? I'm just trying, I can't quite wrap my head around that.
Yeah, so this is saying that so when you run files, the files they have a name to them, right? When you import a file to a different file, right? Let's say I got file A and file B. I'm importing file B into file A.
Yep.
Actually, let's do this. Teardrop. File A, and I got file B. If I run file B inside of file A, import file B. And I run this file here. Jesus Christ. If I run file A is going to take the nickname of main, right? Because this is the main file that's being called. I am calling file A, right? And you know that when I do Python file a.py, right? Because I'm calling this specific file. So when your Python code runs this, it gives this name of main to your file. It's recognizing this. Jesus, oh my Lord. It really hates when I type in main here. I don't know why. Give me a second. There we go. When you run a file, the file that's being called itself, right? The one that you're calling by name, that gets a nickname of main. Well, this main file is importing file B. What is the name of file B? It keeps its original name, right?
Okay.
File B keeps its original name of file B, right? So what that code of if name, just imagine there's underscores there because it doesn't like it when I do the underscores. Look at it automatically
Okay.
converts it. When I import it here, it's going to only run the code of file B whenever I use it. When it has this in here. Because what's happening?
Okay.
Right? Because when I import file B is not called main. It's called its original file name. Right? So therefore, anything inside this main function does not run because the file is not called main, right? Because when it's being imported somewhere else, it's taking up its original name of file B when it's being called to a different file. But let's say instead
When
of
you
running
call file B, you run the file B program, it's now become the new main program.
correct, yes, and then and only then will it run the main function, right? So that's why it's good to put everything inside of a function, and you put it inside this code block. If name is equal to main, then we run everything here. What this does, it keeps the code in here running on its own without you invoking it when you try to call it somewhere else. So that's what the name is, right? It's the alias that your files take whenever you're running them independently as its own, right? So because I call file a.py directly, it gets the name of main underscore. right? But file B, it doesn't get any nickname. It keeps its original name of file B. Make sense?
Yes.
Hopefully that helps. There might be some better explanations online. I'm not the best at explaining this concept because I get confused sometimes if I'm being honest with you. So that's okay.
I think,
Uh-huh.
honestly, I think that cleared it up quite a bit.
Okay, awesome. So this is how this is working. It's going to run all these tests when I call the Python test file directly, which is main.py, right? That's what I called it. It's going to run it directly. If I do this, let's say import main.py or import main. This should not run the test cases. Import, my bad. Is it because I'm calling it main?
Oh yeah, because you deleted the functions that you imported into main. Is that the reason why?
Hold on, line 3. I'm getting an issue here. Oh shoot, you're right. Gosh, dang it. Oh no.
Ah,
Yeah, it's because I deleted the functions. Let's go ahead and copy these. I'll just put them in here directly. I shouldn't get an error. And I have to change this to count letters and change this one to what's it called? Sum of all values. Okay. Same thing with this one. We
oh,
should
there's one
be
more down there. Yep. 10.
10. Yeah. There we go. No more errors. Okay. Now, when I run other main, I import the main file, which is a test. But because I'm not going to run any of this code unless it's being ran directly, it doesn't run the test file, right? It's only going to run when the test cases are being ran individually as a script. But hopefully that answers y'all's questions. All right.
No. Thank you.
Yeah, of course, of course. So here we got another code snippet. This is how it might look on yours. I think that because my theme on my computer, I don't have it all red, but usually it'll look like this, just bleeding on your screen. But notice that it ran all 5 test cases. These all passed. This is how it looks like when it fails, right? And we have that F here. We failed 1 test, and it tells you what it failed. Here's a multiply.py. I'm going to assign this to you guys if you want to do it. Because it's getting late. It's 8:43, so we won't have enough time to do this and then go over it. This one is practice for the unit tests, I believe. Yeah, so write a function named multiply 3 numbers that takes 3 parameters, multiplies them together, and returns a result. Now write a test file for that function that contains at least 5 tests. So if you would like more practice with the test cases, this is a pretty quick assignment, so I encourage you guys to do it. We're not going to cover it though, because it's pretty straightforward. I'll cover any questions that you might have if you struggle with it. But besides that, this is going to be the example for testing it out. Your multiply.py. It's straightforward. It's really just learning how to to use test cases. Uh, I encourage you guys to do it. Don't just kind of brush it off and then not do it. Do at least one or two to kind of understand what the test cases are doing, especially if they're confusing you, because what's going to be your biggest enemy is going to be your test cases. At least for me, doing the assessment, uh, I had no idea what the heck I was reading. I was failing like 90% of my tests, and I felt so overwhelmed just seeing all these errors. Like, yo, what is going on with my code? And that's because I pulled a Keegan, right? I read the instructions, but I did not do the functions how the instructions were telling me to do it and how they were testing it. So I've been there, Keegan. Like the reason why I'm telling you is because I've been in that exact same spot. I've done the same mistake. And I was showing it to my TA, like, look, like I'm confused. Like, are the test case broken? Why is it not working? Um, if I have everything working, it's giving me the result that it's testing for, but I'm getting all these errors. And at the end of the day, even though I got the code correct, that's not how the code should work. And the reason why that's such a big issue is because sure, it might work with this specific scenario, but the test cases are testing for other possible scenarios that could definitely absolutely happen. And that's something that we have to take into account as developers, right? So we have to be able to test all these possible outcomes to ensure that some goober off the streets isn't just messing around with our code and mess it up, right? So when you guys go into your assessments and you're failing your test cases, you want to know what you are reading so you know how to fix it. By the way, AI is not going to help you. I'm telling you that right now. Uh, I would copy and paste my errors into AI, and do you know what AI is going to tell you to do? It's going to tell you if you I don't know what you said, Keegan, you're muted, but it's going to tell you to fix or change the test case. Like, oh, if you just change this test case, it's going to pass. Yeah, no shit, it's going to pass. Like, obviously, but that's because I'm just fixing the test case to ensure that it abides by my function. But test case, it's going to test other possible outcomes. So AI will tell you, yeah, just change this part of the function and it should work. Like, no, dude, I can't do that. And I'm like typing to ChatGPT in all capital cases, like, I can't do that. How many times I gotta tell you, like, I can't change the test cases? I like argue with AI. It was so annoying because like you're so frustrated, but AI is not helpful at all. This is why AI won't change. It won't take your job because, sure, if you tell it to give you create like a calculator app website, it might do it for you. For more complex applications, when something goes down or when it comes to updating, nobody's gonna know that code besides the developers, right? No one's gonna know how to debug these issues. AI, if it's gonna be way too much input for them, and they don't know exactly what we as developers are trying to convey through our code. Uh, so it's not gonna be helpful at all. So just really understand what these test cases are telling you and what these assertions are, right? It's always helpful whenever your code is failing. Go look at test cases. What are they checking for, and what is your code not doing? Right? They might use a get method. It might be deliberately using the get method with a specific response. Remember, I told you it can either return none or return like a number. They might have that in the test case, like, oh, you're supposed to return this string, and your code works, but because it's not returning a specific string typed out like how the test case is asking of you, it'll fail. So you're gonna encounter situations. What's up?
I figured that out, by the way,
Yeah.
on one of the breaks.
Okay.
So
Yeah. Absolutely. So just make sure you're aware of that because it's gonna test for, it's gonna be very specific. You can't miss a space, a quotation mark. It can't be a number off. So reading a test case is gonna be very important. So definitely try out multiply.py. It's not an assignment that we're gonna take half an hour and then go over because it's not too much to it. Just really understanding that you have to use your function, create test data, and then compare them to what the correct answer should be. That's all you do. All right. All right. The next thing that I'm going to leave you with, and we're not going to start today. You guys can start it today if you guys want on your own, but we're going to take all of tomorrow to do. It's going to be the lemonade stand.py. This is probably going to be the hardest classes and object assignment that we'll do throughout the course. Um, this is pretty close to where your assessment will be. If the streaming guide was like a 4 or 5, this is like a 6, 6.5. So it's definitely a little bit higher than the streaming guide. So if you can do the limited stand-up pie with no issues and you feel pretty confident, then you should feel like you're in good hands. But we're gonna take all of tomorrow to do this. We'll break up into breakup rooms and then we'll tackle it and then I'll help you guys individually. Yeah, this is gonna be the hardest one that we really do throughout the rest of this course, this assignment here. Do you have any questions before we cut for the night?
Why is it
Just
hard?
a heads up, Roger, I got another long day at work
Okay.
tomorrow, so
Yeah.
I should be able to show up later, but it's just depending on how my day's going.
Yeah, no problem. We'll take about half of the time to do this in class, and then the other half will be me coding it, and showing you guys the right way. So just, if you get a chance, if you're doing this, just review the video. Nick asked, why is it hard? Let's look at it. What is it asking of you? I haven't seen it in a while, so I do apologize. Well, first and foremost, you're gonna have test cases already made for you. All right, so once you're done with the assignment, you're going to run the test cases against your code, and you should see if it passed or not. Right? So it'll give you like a pretty close scenario or environment of how it's going to look like when you get into your assessment. And then here is going to be your empty file. And here is the entire assignment itself. Let's look at it. You have different classes. You have menu item, sales for day, lemonade stand. The complexity of this assignment really is going to be how your classes interact with your other classes, right? I always lose people whenever we start talking about data structures that have an object saved into it. And these objects also have data members that have data structures, right? So imagine a lemonade stand that has a menu, which is a list of objects, right? Lemonade, so on and so forth. And then these lists of objects might have, let me rephrase that. Let's look at, ignore that scenario I just gave you. Lemonade stand is going to have a data structure that's going to have sales for day. This sales for day is going to have it's going to be a dictionary of sales for day objects. This sales for day objects is going to have an entire list or dictionary of all the objects that you sold this day. So you're having to access a data member from lemonade stand, which is a list of objects. And then as you go through every object, you're going through their sales for that day, like a record log pretty much. And then those are objects themselves. That's where the complexity of this happens. Does that answer your question, Kevin?
Yes.
Right. So it's really understanding data structures and how to nest your way in them. The biggest tip I can give you is when you create a list or a dictionary, what you need to do is say something like list. Let's say sales for day is your list, right? And this is supposed to be, let's say the key. I highly recommend add comments. Key is the day. Value is sales object, right? Because when you go and you start manipulating and accessing these data structures, it always gets you guys. You forget what exactly is assigned to these dictionaries. And then you're having to backtrack, look through the directions. What the heck is sales for day supposed to be? I don't remember what I'm saving in here. So it's always helpful. Just annotate what is actually being saved in these data structures so you don't get confused later on. So definitely do that. The next thing I recommend to help your code easier, this assignment doesn't have it structured that way, but I recommend you do it. I want you to create all these different objects or classes, my bad, all these classes in their own respective file, right? So menu item will be a class in its own file. Sales for day, its own file. Lemonade stand in its own file, and then you're gonna have one big main.py file that's gonna use these, right? You're going to import the class that you need whenever you're going to create it in another class, right? For example, if the lemonade stand should be able to create menu items, then you need to import the menu item class into the lemonade stand class to use it, right? So give all these classes their own individual file. And the last thing that you need to do afterwards is you need to update the imports here. If you do give them their own files, you need to ensure that you import from the right area. As you see here, as it stands, all these classes are in their own are all in one file, which is going to be called lemonade stand. So you should be able to do something like from menu item import menu item, right? Or something like that. From sales for day import sales for day, the class itself, right? So you should have individual imports for the classes from the respective files. As it stands right now, it's formatted so they're all within one file. The reason I tell you that is because you don't want to get to 200 lines of code and you're having to scroll up and down continuously. Like, oh, how did the menu item class work? Let me go all the way back up, and you're scrolling looking for a specific method or class, and it's like overwhelming. So it's gonna be easier if you have it in the respective file, and then you can navigate to the file itself or where the class is at, so you can see the definition quickly. Does that make sense? We will talk more about this tomorrow. This is going to be tomorrow's assignment. I'm just saying it for those of you who might not be here or might come late. That's how you should approach this. And that's going to conclude today's class. Let me go ahead and stop the recording.